Hey everyone, so today we're going to be looking at these three projectile motion example problems. From a videotape, it was observed that a pro football player kicked a football 126 feet during a measured time of 3.6 seconds. Determine the initial speed of the ball and the angle theta at which it was kicked. Okay, so we're going to first look at this in the horizontal x direction. And we're just going to say that going forward, positive is up and positive is also to the right. So in the x direction, we know that the following equation applies. So we're going to say s equals s sub 0 in the x plus v sub 0 in the x times t. So we know that this 126 feet, this is our s in the x direction. So we can say 126 feet equals 0, because we're going to assume that this point here is 0, plus v sub 0 x, and that's what we're going to be solving for. And 3.6 is going to be our time, because the ball traveled 126 feet in 3.6 seconds. So doing some algebra, our v sub 0 x is going to work out to give us 35 feet per second. So now we can look at the y direction of our velocity. So in the y direction, we know these equations apply. So s equals s of 0 in the y plus v sub 0 y times t plus 1/2 a t squared. So we know our a is going to be gravity, and we're using feet per second, so we're going to say 32.2 feet per second squared is going to be our a. Our time is going to be 3.6 again. And let's just begin to plug in what we know. So we're going to say this is 0, starting from the ground where he's kicking it, equals 0 plus vy times 3.6 plus 1/2 32.2, 3.6 squared. So clean this up a little bit. So now we can solve for the velocity in the y direction, and that's going to give us 57.9 feet per second. And the problem is asking us for the speed. And we know speed is the magnitude of the velocity. So what we're going to do is we're going to take the square root of the sum of the squares of the velocity components. So we're going to say our v sub 0 x squared plus our v y squared, and that's going to give us 35 squared plus 57.9 squared, and that will work out to give us about 68 feet per second is the speed, just taking the magnitude. So there we go. So we have one more piece of this problem left to solve, and they just want to know theta. And this is just simple trig. Theta is just going to be equal to inverse tangent of v sub 0 y over v sub 0 x, which is going to be the inverse tangent of 57.9 over 35, and that will give us about 59 degrees. A golf ball is struck with a velocity of 80 feet per second as shown. Determine the distance d to where it will land. Okay, so we are going to write down what we know. So our x direction, we're going to use this equation for position. So we're going to say s of x equals s sub 0 x plus v sub 0 x of times t. And in our y direction, we're going to say s of y equals 0y plus v sub 0y times t plus 1/2 a t squared. And we are going to use a as gravity, and that's going to be 32.2 feet per second. And now we can start looking at the problem and what we're given. So right away, we're going to know that we're going to use our x and our y equations. We're going to break this down and solve this again in the horizontal motion and the vertical. So right away, you see that we're going to have to use what we know from the problem to solve our v sub 0 x and our v sub 0 y. So to do that, we're going to look at what we're given, which is a v of a equals 80 feet per second. And we're just going to use some trig, and we're going to write what we know. So we're going to use VA cosine of this angle. And if you look here, we have a 45 degrees, but we also, since this is on a hill, we're going to add this 10 degrees. So right here, this is going to be a 55-degree angle. So we're going to say this right here is 55. So we're going to write our x component as VA, which is 80, times the cosine of 55, and up here we're going to say VA again, which is 80, is sine of 55 degrees. 80 cosine of 50, 80 sine of 55. So we can use that to plug in, but first let's just write out what this is actually equal to. 65.5 about, which is our velocity in the y direction. And we know that our x direction is going to be equal to about 45.9 feet per second. So that's great. So we can start making a move now into plugging in what we know to solve these equations. So in the x direction, we're going to use our x equation, s of x equals times t. So our s of x, we're going to say is d, right here, this d. So we're going to say d cosine of 10. And that's just going to be like looking at a triangle like this. So here's our 10 degrees right here. So our x component would be d cosine of 10, and our y would be d sine of 10. So we're going to say d cosine of 10 degrees. That's going to give us this position over here to where B is, where this ball lands. I drew my triangle a little too far over, but that's going to give us this point right here. And that's going to equal our initial position, which is 0, plus our y or our x component of the velocity, which is 45.9, which we solved right up here, times t. So in the y direction, we can say s of y equals our v sub 0y, which we solved, plus 1/2 a t squared. So we're going to do the same thing. So we're going to say our s and the y is going to be equal to d sine of 10 degrees, which we solved up here. That's where the ball lands at that point B, equals 0, which is our initial over here, plus what we know, 80 times sine of 55, our y component of the velocity, 65.5 times t, plus 1/2 a, that's just going to be our gravity, pulling down so it's negative, t squared. So now we have two equations, and we're just going to use, we can just solve for the variable. So if we say t equals d cosine 10 degrees over 45.9, and then we can plug that t in here, that'll give us a d value of 166 feet. And then we can solve for t, which will give us 3.568 seconds. Okay, so let's look at one more. Determine the maximum height on the wall to which the firefighter can project water from the hose if the speed of the water at the nozzle is V sub c equals 48 feet per second. Okay, so we're going to write always what we know, so in the x direction and in the y direction. We know the following equations. So for x, we can say s equals s sub 0 x plus v times t. And for y, we know that s sub 0 plus v sub 0 t plus 1/2 a t squared equals s. So let's look at this v sub c, because like before, we know that we're going to need to find the x and the y components of that to be able to solve this problem with these expressions. So let's say this is our VC, and we know that equals 48 feet per second. So the x component of this and the y component of this are all going to be dependent on this angle theta, which they actually don't give us. So we're going to have to solve for that. But we can say 48 sine theta is going to be our y component of the velocity, and 48 cosine of theta is going to be our x component of the velocity. So let's start plugging in what we know. So we're going to say 30, starting in the x, because we know that this length right here in the x direction is 30, is going to be equal to 0 plus 48 cosine of theta times time. So let's solve for t here by saying t equals 30 over 48 cosine of theta. And we're going to use this t expression down here to solve for theta because we're not given a time or an angle. But we can pretty easily solve for t by just plugging in once we fill out our y equation here. So we can say 0 equals 3 for s of 0 because we are 3 feet off the ground here, plus our y component of the velocity, 48 sine of theta times t, plus 1/2 a, which again is just going to be our gravity. So we're going to say negative 32.2 t squared. So we can plug in for time. That's going to give us 0 equals 3 plus 48 sine of theta times 30 over 48 cosine of theta plus 1/2 negative 32.2 times 30 48 cosine of theta squared. So we're going to solve for theta here. We can take it a step broken down. That'll give us something that looks like this. And then we're just going to keep solving. And theta is going to end up being 6.41 degrees, or you could call it 77.9 degrees, depending on which way you're looking at it. And that's our final answer. Thank you for watching. If you like this video, please be sure to give it a thumbs up and subscribe. That really helps support my channel and helps me continue making videos for you guys. I'll see you next time.